So hi, I'm Mahidhar Tatineni. So I'll be talking about Python for HPC. This is a talk that Andrea Zonka developed. He couldn't make it, so I'm just filling in. I think I've worked through all of his examples, so everything looks good. So, but and Andrea has nice videos explaining how to use all the notebooks that he has. So the outline of the talk, there's an introduction to Jupyter Notebooks and Jupyter Lab. You probably don't need this because we've been using notebooks all over the place, but I can just do a brief overview. Then we look at single node Python code optimization with Number, and then followed by a couple of tutorials on Dask. Just one doing an intro and then one going in depth for multi-core and out of core. We won't be doing the multi-node computing today because I don't think there's enough time. But Andrea in his repo from last year has more info on how to do that if you're interested. And the YouTube videos that you'll be watching, they're in a playlist and you can see that one too. So so those are, that's kind of the overview of what we're going to do. So let's take a look. So Jupyter Notebooks and Jupyter Lab, basically browser-based interactive console to let you kind of develop Python code and run Python code. You can support multiple sessions in browser tabs, and basically each session will have a kernel that's executing the computation, and the notebook itself is saved in JSON format, and you can always go back to it and share it and so on. And you had a nice link here with examples of notebooks in kind of a real world physics applications. So you can take a look at that. I mean, we're not going to do those, but he had a nice link for that. The nice thing with notebooks is you can run them on your laptop or your desktop to start with and develop with those. And then, so you would have basically the notebook running on the as a local web application in your browser. And you can have Python or Julia or other even R kernels running on your laptop. And so you can do your initial development work using these notebooks. So, and once you're kind of ready to say, oh, okay, this works fine at the small scale, let me go to a larger scale, you can go onto a machine like Expanse, spin up the notebook on an Expanse compute node, which has a lot more resources than your laptop or desktop. But you are still accessing it from your laptop over HTTPS, the way we've set it up. And you're still running the same kernels, except now you have more resources, more memory, more CPU power, and so on. So that's kind of a nice way to do development that translates from your local machine to the large-scale supercomputers. And today you're going to look at basically the number aspect, which is going to optimize at the individual code level, and then the Dask aspect, which basically lets you distribute both as processes and threads, and then also distribute over nodes, which basically unlocks the bigger machine that you have access to. So you can get a lot more resources. So today's workshop, basically, I have this presentation already in the GitHub site. So you can just clone the repo, or if you've already cloned it, just do a pull to get the updated versions. I uploaded most of the content like maybe an hour ago, or the last update was an hour ago. So you should, if you pulled it in this morning, you should be good. And but you can just do another one just to get the most recent part. So so once you have this, there is a Python HPC directory So you can go to 4.2a underscore Python underscore for underscore HPC in this repo, and essentially run this launch script that will use Galileo under the covers and get you a Jupyter Lab instance. So once your job is running, you can open the browser and connect to the URL that comes out. So you're probably already familiar with this because we've done a few of these this week already. So basically, we're going to start with Number. It's just a just-in-time compiler for Python based on LLVM, which is kind of backends a lot of compilers. It turns Python code into machine code on the fly. But the nice thing is, once it's in machine code format, it's going to be a lot faster, and you'll see the examples today. So as I was saying earlier, the entire talk is structured. Andrea has it structured so that it's synchronized with content on YouTube. So we already did looked at the getting into the training account. There is this link which has all the YouTube videos in a playlist, but I also have individual videos in each of the sorry, I'm going the wrong way. Each of the slides, so you can click in. So the first thing we can do is go to this link and watch the first video, which is an introduction. You can speed that up a little bit because Andrea's been kind of deliberately keeping the pace slow so that people can follow along. But I think if you do 1.25x, you can probably follow along still fine. Basically, I want you all to do this so that you can run this step here, the launch Jupyter underscore singularity.shell piece after you clone the repo, of course. Get your notebook, and there is that initial Python notebook that just has simple tests. So please go ahead and run those. And I'll be watching the Slack channel for any questions that come up if you have trouble with using the repo, or if you're having trouble getting the notebook going. I already updated it with the reservation for today, so you should be able to get a node pretty quick and run. So go ahead and do that, and then we'll meet back in like 15 minutes. It's a really quick thing once you have the notebook up. The intro piece of it. Let me stop sharing this and show you how it looks, because I already ran all of it just to make sure. So let's see. Let me go back and share the entire desktop so that I don't have to keep doing this. Okay. So I hope everyone can see the notebook. So basically, it's a very simple notebook that has simple Python things to test out that the notebook's working, and you have a node. You can figure out which host it's running on. Like here, my example was running on exp-1-52, and it just makes sure that you're not on the login node. We don't want to be running on the login node. And also make sure that you're picking up the right container. So those are the things to check. So please go ahead and do this, and I will watch for the main room to see how things are going. And actually, if you can give a thumbs up if everything works, that'll be good. Then I'll know people are following along. Let's just take a quick look at what you should have seen already. I can see that a lot of people were running the Galileo jobs, I think at least 10 plus. So hopefully you're making progress. And I saw some thumbs up. But basically what you need to go through is this intro.pynb notebook. And you can see it's just doing simple, like printing out hello world, doing some simple math, plotting something. The main thing to pick up from here is the host name. You don't need this right away, but there's a place where you'll need it further down the road. So just keep this intro tab alive in case you need to go back and find that node. So the next slide, let me get that up. There are two videos, basically. They're pretty short, 10 minutes each. So I think we can do both and reconvene. But before I do that, is someone still stuck? If so, just put a note in the main room Slack channel and I can follow up. As far as I can see, there are no questions there. So hopefully people are okay. What we are doing now is doing a couple of number notebooks, one that goes over the basics and then one that kind of has a NumPy component. So you can look at those two videos. And before you head off, let me show you how it looks when it's done. So you can kind of just a quick overview of what's going on. So you get the number version, you have some functions that you use without number and with number and kind of compare how the performance looks and see how much faster it is by doing this compiled version. And you'll see that it's actually faster even than using something like NumPy, which actually backends to some pretty fast linear algebra and other routines, but it still is better to have a precompiled code, essentially. So you should be able to watch the video and just step through this. And if you have questions, again, drop them into the main room chat. So there's two videos of 10 minutes each. So we can sync up again, and I'm watching the main room and I can answer any questions. And if you have any trouble, let me know. So let me go back to the slides. So we are on slide 12 right now, if you're following along. So Cindy I think looks like people are okay. So we'll take another pause and then come back. So yeah, just wanted to check if everyone was progressing okay. Looks like all the jobs are still running. So hopefully you all were able to go through the two things, the basic number notebook, which kind of goes over and shows you how much things speed up just by using number for your code. And then the NumPy aspect, where the nice thing is it is designed to use NumPy where it can. So you can actually pass NumPy arrays. You can create compiled functions, and also like a lot of the NumPy functions themselves are already available in the no Python mode, which is optimized basically. So that kind of gives you a good overview of the benefits that you can get. So the next two are going like a step further with basically using threads, because I mean, these nodes have a lot of cores, and I think by default everything got run in the compute partition, asking for all 128 cores in this example. So you have a lot of cores that you can use. So the next couple of things basically show you how to do that at a node level, basically use the threads and go into more detail. And I think the last one is a real world astrophysics example that Andrea put together. I think he works on in that area, so he's kind of familiar with all the kind of work that happens. So that puts together, the example puts together usage of pandas and number, and is doing basically cosmology pixelization kind of application, I think. So you can take a look at that. So I think, let me go back to the slide. These are two more 10-minute videos, I think. Yeah. So I want to stop and see if there are any questions in the main room. Doesn't look like it. So Cindy, we can go another 20. And maybe we can take a break after that, because that will be about an hour and 15 minutes in. So let's do the 20 minutes with number 2 and number 3 notebooks, and come back, and I'll see if there are any questions, and then we'll take a break and come back and do the Dask stuff afterwards. So this part basically is showing you how the just-in-time compiler and the pre-compiled stuff is giving you a lot of performance advantage. And once we have this, we can go back and see, hey, can we use the resources on the node and on multiple nodes? And that's where Dask comes in also. Because sometimes, just threading to a lot, all the threads on a single task might not work well. So you can use Dask and kind of schedule some of the work. So we'll look at those videos after this. So let's join back maybe around 11. I think that might give enough time for people to catch up and look at things. And put a thumbs up if you if you have things working, just so we know. Let's see. I just saw one question on the main room, basically asking if number allows you to set the number of threads. So yeah, by default, it's going to use all the threads that it finds. I mean, all the cores it finds. But there is a environment variable you can set, number_num threads, or I think there's also a function that you can invoke to set the number of threads. And I have the link under David's question that has a lot more detail, so you can go look at it in the documentation. Other than that, hopefully everybody was able to run through those last two number tutorials. You can see basically the multi-threading, the automatic one, then with the p-range, and then basically giving you a little bit more control, and then then the last part talks about external multi-threading using Dask. You can run through that. It's going to work because everything is set up, but basically that's another way of doing it. But that kind of leads into the Dask part that we are going to do next. And then the astrophysics example was just a real world example that kind of gives you reason to do this, use something like number. Basically, the takeaway is that you can optimize the run using the just-in-time compiler. Basically, you can get your Python code optimized a lot more and basically run a lot faster. And if you work through the worksheet, you probably saw those speedups were quite big. So the next part that we're going to go into is Dask. And we'll start with the simple case with a for loop style code and using Dask.delayed so that things can be optimized. But I think maybe this is a good time to take a 5-minute break. Maybe let's get back at 11:10, and then we can basically go into the next part of the talk, which will be starting with the Dask stuff. So yeah, so we can go on to the Dask part. So let me quickly open the presentation. So you should be going to this Dask delayed presentation and following along. Before you go off there, I just wanted to quickly take a look at that. I mean, I've run these before, so I'm just going to give you a quick overview of what's there. So there's documentation. There's also this client cluster setup, basically with the number of workers set to 4. And if you do client.cluster, it'll tell you like the workers are for, and then how many threads are there, and all kinds of things. So you have a lot of information. One thing is this dashboard here, if you notice, it's got a 127.0.0.1 address. That's localhost on the node. So you can do a couple of things. You can either forward that port, or since we have our nodes completely accessible from outside, when your job is running, you can basically run, you can just replace the 127 address with your node address. So like in my case, exp152 was what was running the job. So I just did exp152.expanse.stc.edu. So you can do that if you want to, look at the scheduler. And if you remember, the host name was there in the intro.py NB notebook. Basically, that's where I got it from. So if you're looking for that, you can go there. Other than that, I think you can follow along the basics. It tells you how to basically use this dash.delayed to kind of basically let Dash figure out if the functions can be done independent of each other, and get some parallelism into that and get speed up. So you'll see how this works out. In the original video, you'll see that Andrea had mention of a visualize function, and that is not going to work. And I have it out of the notebook right now, but if you see that in the video and you wonder why you don't see those graphs, that's missing because I took it out. And that's because the container that Andrea built for this year doesn't have one of the GraphViz programs that's needed. So we can add that in and make another container, but for today, we probably don't need it, and you can just look at the video. So go ahead, and we'll come back in 15 minutes, so around 11:28. As always, I'll watch the main room for questions. We have like the last two videos. Let me get the slide deck up. There's actually another one right at the end, which is a Dask array one. That's also a short one. We probably won't get to all of them, but you can do them offline, or not offline, but after the talk, or this evening. The only thing to remember is if you want to run these again, make sure you take the reservation out because the reservation for today will expire. You can change it to tomorrow's reservation, or just run it without the reservation. It's probably going to get through okay. So the next basically two talks, two videos are about Dask arrays and Dask distributed options. So let me close this out and show you what's in them. So one thing is, before you go on to the next exercise, make sure you do a client.close on this particular Dask basically notebook, because it's going to tie up some resources otherwise, and you might not be able to run the other ones. So just close this out and then go back and run the next one. And I think in each of those notebooks right at the end, you'll see the shutdown, I think. And in my case, it basically I think I just stopped the whole thing. You can also just stop the kernel. That will be fine too. So going into what's there, basically, Dask arrays lets you do parallel larger than what memory is available, memory and large arrays essentially be able to do distributed NumPy. So that lets you scale both in performance and also in the sizes of the problems you can do. So, so anyway, that's the Dask arrays notebook, and then there's the Dask distributed, but which lets you do the tasks in a distributed fashion. And again, there are lots of different schedulers. You can do threaded, you can do processes, you can do a distributed, uh, even doing multiple machines. We won't get into all of these today, but just so you know, it's there. One thing I forgot to mention is some of these videos, I mean, sorry, notebooks have like small homeworks essentially, like where they let exercises. Let me go back to the other one. And if there are 3 dots, you can just expand that if you want to see, like, for example, I think this one was one, if you want to see what the code is. So, but all of them should have the answers built in. They're just not visible immediately. So go ahead and run these two. I think that will take us to noon, and we can transition to the next talk. So when that happens, so Cindy, I think you can just grab the session at that point.